Welcome to this video about GAIT analysis, and in this special case with pre-recorded data from Medilogic and the data treatment with the software MATLAB. In this video I will show you the workflow, what is to do for the data treatment and which steps are necessary to make the data treatment. At the beginning, what is plantar pressure? So you can do GAIT analysis with different ways and different measurement types. You can make a video analysis. You can also measure with force plates, and you can also measure the plantar distribution with pressure sensors. And therefore, you could use a plate system, which is here shown as an example from the company Series, and you can also choose systems from Nobel and Medilogic, and in our case the data is recorded with Medilogic, but there is also a system from Nobel which you can see in this picture. You put the insoles inside of your shoes and you have a hardware to send your data to the PC or to work as a data logger. You can see you must fix your wires on the body of the person which you want to measure, and then you can start your measurement. What's the principle about the measurement? So you have a physical property. The physical property in this case is the pressure between the foot and the sole of the shoe. So you put it in between, and therefore you measure the pressure in this layer, and the pressure is converted with the help of a sensor to a digital value. So from the physical value you get an changing resistance, and that you can convert to an electric value, and with the analog digital converter you can convert it to a digital value which you can afterwards read on your PC in a time diagram. So the system which was used is the wireless system from Medilogic. You can see there are the insoles. You can buy them in different insole sizes, in shoe sizes, and you have a sending unit and a receiving unit which you can plug into your PC. And now the system is without cables, so it's a wireless system, but in this special case it was this system. So you have options for the insole size, and the size of the single sensor is not varying, so therefore you have a higher amount of sensors in a larger shoe, so you have more sensors in there. The sampling rate is choosable from 25 Hz to 400 Hz, and the resolution of one sensor is 8-bit, and the measurable value ranges from 0 to 64 Newton per square centimeter. We see later on how to convert this value for our data treatment. And you can use the system in two different modes. You can use it as a data logger or via the sending and receiving unit in the live mode on the PC, so you can use it that way. Okay, and the next step is to have a procedure for the measurement. Therefore you have to define the insole size. So what's the definition of the insole size? The insole must fit in the shoe without bending on the end of the shoe. So when it is too large, the sensor got bent, and according to that, or due to that, you have an offset in the measurement, and that is not good. You want to avoid to have offset according to the bended sensor. And also in too small sensor is bad, because it's possible that you don't measure the pressure in your toe section, and the toe section is also a very interesting part during the GAIT analysis. So if you have chosen the right one to your shoe size, you can prepare the test person, and for the preparation you need to fix all the wires on the person so that they are not wobbling around to loosen, and then you can perform your first offset measurement. For the first offset measurement you have to sit on the table and have the system started and record for 30 seconds, and then you have your offset measurement, and this offset measurement maps your pressure in the shoe in an unloaded situation. Then you perform your main measurement, so your GAIT analysis part, and after that you make a second offset measurement to have an offset for your whole measurement. And this is stated because as often as necessary, because when you got disturbed during your measurement, you should cancel out this measurement as well, but then you have to re-measure the offset measurement so that it is in front of your main measurement or afterward your measurement. The files we got from the systems are comma separated values, therefore is the file ending .csv, and you have the raw sensor files for the right foot and for the left foot, and these are the files which we are investigating, and you also have a cyclogram for the center of pressure and a gate line for the right and for the left foot. So you can also load this data and plot the gate line or the center of pressure, but we are investigating in the raw sensor data file. This data file looks somehow like this. In the first row you have the sensor number, and this sensor number is directly linked to your insole size, and you can then see, okay, sensor 17 is in this area in the foot and have these sensor values. Then you have a minimum value over the whole measurement, a maximum value over the whole measurement, and the 20% average value. And in the fifth column, the measurement data starts. So here is the first measurement point, and then according to the sampling rate, this is the next sensor value. Good. And for the offset measurement, this is the data analysis workflow. I've sketched it up, what we are doing in the next steps. So we have the offset measurement, the main measurement, and the second offset measurement, and we are building the mean over the rows for this particular measurement and for this particular measurement. So it's the same data treatment part for both, and we can use the command mean in MATLAB, and then we build a mean over the rows out of these two measurements, and we end up with a single offset measurement variable. Then we have these two variables and subtract the offset from the main measurement, and we end up with the main without offset. I think that's pretty clear. It's not the command mean in this case. We only have to apply the subtract, define the foot region afterwards. So this is according or due to the investigation which you want to make. So in our case, for the simplicity, we are taking only 4 regions. We take the toe region, the forefoot region, the midfoot and the rear foot region. But when you have done it with this 4 regions, you also can make it more detailed with more regions. And after this definition, one thing I want to say to the definition is you have to look up where a toe region is during the measurement. So is it in the first 2 sensor lines, or are it only the first one? And as well the heel region, the midfoot region and the forefoot region. you see the sensor numbers in there, and then you have to define the sensor numbers for the specific region. And then we have the amount n of sensors for the toes region, and we build the mean over the sensors in this region and end up with a mean toes, mean forefoot, mean midfoot, and mean rear foot or heel. I think this is pretty clear. But the next step is to plot the data to see what's in the data, and therefore I have summed up all sensors, not only the specific regions, so I have built the sum over all of these sensors. So I've made the sum out of these sensors to see this GAIT specific behavior of the line. So this first, the initial impact, the heel strike in this case, and then you see the forces going down during the mid stance phase, and you can see the increasing of the force during the toe off. And then in this part is the second foot in action, and then we have the same foot again striking with the heel, and so on and so on. So I have 6 stance phases in here, and the commands which are useful to make this are to make up a new figure, use plot and hold on to plot new data over the existing data. In this plot I have used these variables, so there I have summed up all sensor data to see the whole pressure underneath the foot. And for the next plot I have used these variables, so the mean out of the regions, and you can see it on the y-axis. So this is a sum because we are in the range of 1000, and this is a mean value because it's the mean value in these regions in Newton per square centimeter. So you can see this one is the toe, the forefoot, the midfoot, and the heel. We can look up if it's true. So the heel is this color. Okay, the heel is the first one, that's true. Then the midfoot is in action here, down here. Then you have the forefoot, and the last one is the toe section. So looks good in this case. And then we have the measurement time in seconds, and we choose 6 stance phases. I have written it down here. We choose 6 stance phases to build a mean value out of 6 stance phases. That's only for example. It's not best practice or something like this. It's only to get the first data treatment done. So we choose 6-1, and on the next figure we can see what we are doing with that. We are identifying every single stance phase. As I told you, you can see it where your first pressure starts. So this is for the first stance phase, the start point. Oh, that one annoying. And the second line is the end of the first stance phase. Then this section in between is not interesting for us when we are wanting to plot our data. And so we have the first, second, third, fourth, fifth, and sixth stance phase. This one we are cutting out. When we've cut the data, we have to do a time normalization of the stance phases for every region, and we are using the command intab1 in MATLAB. You will see it later on. And we are calculating the average value and the standard deviation of every region. And for the standard deviation, the new command is std, mean we have used already. And then we calculate the maximum pressure in every region. Therefore, there's also a pretty simple command. We use the max command. We are calculating the on and off point in time in every region. So we define a threshold value, a pressure value on the y-axis. We calculate the on point in time for every region, the off point in time. We calculate the total loading time for every region, and we can use the command find for that. And this is the graph which we are ending up. So we have the stance phase. The stance phase in the GAIT cycle is about 60%, but I've chosen for the stance phase 100%, and the pressure is in Newton per square centimeter for the region. And legend would be interesting in this plot, but it's only for an example. As I stated here, you can see the heel in the first area, then the second one which is starting is the midfoot area, the forefoot region and the toe region during the toe off, and we have also linked the maximum value in there, and you can see the number values as well. Okay, and in the next videos we look in the MATLAB code and how we do this single steps to get to this plot.